We're going to talk about pointers in this screencast, and pointers tend to be one of those topics that give new programmers a lot of problems and a lot of difficulty understanding. And in class, we spent over an hour talking about this, so I'm obviously not going to be able to spend that kind of time in this screencast. And I expect you'll probably have to watch the screencast multiple times to follow everything. So the two main operators you use are the ampersand and the asterisk to work with pointers. So let's just review. You know, if you just want a regular variable, you give it the type, in this case int, and then you give the variable name. Here we just called it x, and I've assigned it a value of 123. Nothing new here. So we use the asterisk if we want to create a pointer type. So instead of int, we want to create what's called a pointer to int. So that's how you would read this. So this type right here, this is a pointer to int, and it has the name x pointer. You call it anything you want, just like you can with any variable. And then the ampersand is used to take the address of a variable. So ampersand starts with a, take address of starts with a, so you kind of remember that. So this is how you use it. So this is saying I've got a pointer to a type int named x pointer, and it's equal to the address of x. So it's pointing up to this variable up here, and it's saying wherever this lives in memory, I want you to assign that to x pointer. Remember, all variables live in memory somewhere. So this is going to get some big long hex address value. Okay, so and if we want to see that hex address value, we can just see out x pointer itself, and that'll give us the address of where x lives. Okay, and so this is sometimes so that's all pretty clear. Everything's got one use so far. So what happens though is these same operators get used for more than one thing. So the asterisk is also used to dereference a pointer, and by dereferencing a pointer, what I mean is when you have a pointer to a variable, you don't typically want the address. You don't want the value of that pointer. You want to know what that pointer points to. So doing this, the star and these parentheses are just here for clarity. They're optional. But so you dereference x pointer. This statement is going to print out 123. Okay, this says dereference x pointer. So give me whatever its address points to, and give me that value. Okay. All right, so some things are a little tricky with pointers, and you can get yourself in trouble. This will compile. It probably shouldn't. This is saying give me, and by the way, whether you put space here, whether you put the asterisk next to int or the asterisk next to the variable name, doesn't matter. I prefer to keep it close to the type. Okay, so this says I want a pointer to car, and I'm going to call it full name, and I want to give that this constant string. And I'm just putting my name in here. Now, the reason this isn't a good idea is this isn't a variable. This is a constant. Where does this live in memory? And the answer is it might not. This actually, especially in an embedded world, this could get put into read-only memory, into ROM. So telling it that this is a car pointer means you might want to change this in the future. So you're much better off if you're going to use constant strings using constant char pointer, and then doing that. And we'll look about that a little bit more in code as well. I just want you to know that there are you can get some strange errors. So and this should probably have single quotes. So if you dereferenced full name now, and you tried to assign it a value after you call it a const, then you're going to get an error. It's not going to let you do it because you promised it was constant and not changing it. In fact, as far as you know, it's stored in a section of ROM, not RAM. So, oops, sorry. Okay, so let's go over to Eclipse. Okay, I created some code already just to save us some time. Print in pointer. This is going to take a pointer to an int, and it's going to print out what the actual address of the pointer is, and then it's going to print out the value of whatever the pointer points to. So this is sort of like our example. So x gets 123. I've created a pointer to x. I take the address of x, put it in pointer to x, and then I did it again for y. And then in addition, of course, pointer x and pointer y themselves live at a memory location. So first I'm going to show you where they live by taking the address of pointer x and pointer y, and then I'm going to print out the value of pointer x, and then print out the value of pointer y. And then that'll be enough for right now. Then let's just say return here. Okay, so let's compile that, and then let's run that. Okay, let me make this a little bit bigger so we can see what's going on. Okay, so you can see some funny hex memory address for X, FF08, and FF00 is where the pointer of the Y lives. So pointer X has a value of 28FF0C, so that's the address for where X is. And then it's saying, but that pointer, what lives at that pointer is 123. So you can see it's got X. Pointer Y is pointing to Y. So that lives at 28FF04, and it points to 500. Okay, so if we scroll up to our print routine, so we're printing this hex value by just sending the pointer itself out, and when we dereference the pointer, we get the value. So the first one prints out this, the second one with the dereferencing points out the value of 123, and in the case of Y, there's the address of Y, and there's the value of Y. Okay, so let's take out our return, and we can do more things here. We can take our pointer of Y and we can say, hey, point to the same thing as pointer of X, and then we'll print that out so that we'll see they have the same underlying address and the same underlying value. And then we can say, hey, dereference whatever pointer of Y points to, and instead of getting its value, go ahead and assign a new value to that. Okay, and then we'll print that out, and then we'll also print out what X points to, and then we'll just directly point out what X and Y equals. And actually we'll do this as well. Down here we're going to point out again the addresses of pointer of X and pointer of Y. So and then we'll just hit our return there. Okay, so this was our original output, and then starting right here is where we change the Y pointer to point to the same thing X. So you can see these addresses are the same now. Y and X are pointing to the same thing, which has 123. And then when we change the value of Y and print it out again, this did not change. It's still pointing to the same address, but its value changed from 123 to 456. Okay, and then you can see that I printed out X, and it's the same. So X was pointing to that same memory location. Pointer Y, which is a bad name now. It's not pointing to Y. It's really pointing to X. So it's X and Y both print out the same thing, and they both have the same address. And you can see that X is what actually got changed, even though we changed it through pointer of Y, and Y still has the same value. And then these numbers, X, the pointer of X and the pointer of Y, they haven't changed. They're still at F8 and F0, just like they were up here. So we haven't changed their actual addresses, just what the things they're pointing to. Okay, so I think that's a lot to absorb right there, and I think you might want to type this code in yourselves and play with it and get a feel for what's going on here rather than just listening. So I'm just going to slowly scroll down here so you can see it all, and you can of course pause the video to get everything. So we'll just start all the way at the top with our standards, and there's the print pointer routine, and then here's main, and then setting up the variables, and then just printing out some messages. Okay, right down to there. And then we'll pick up with in the next lesson how you use pointers with arrays, and sort of why people like pointers. You can get in trouble with pointers, but you can also do some fast things with pointers.